web app using JavaEE, Spring Security, and Apache Fortress. For the next 50 minutes, we're going to think about what a web app would look like if we spared no expense for security. Come on in, guys. So that's me. And when I'm not out riding with my buddies, I'm training for a 200-mile gravel race that's in 2 weeks, and called the Dirty Kansas. And that's in 1 day. Last year it took me 20 hours. This year I'm going to try to complete it in 16. And other than that, I'm trying to get work done with Symas as a software architect. And I'm a member of the PMC of Apache Directory, and I moonlight with OpenLDAP. Okay, so today we're going to look at a couple examples. These examples are in my public GitHub account. Right there, the first one's called the Apache Fortress demo. And that is combining Apache Fortress, which is my project, which is a security system, with JavaEE and Spring Security for an end-to-end security model. And the second one is called the Fortress SAML demo, and that's going to be using Apache Fortress and SAML as an endpoint. So as we look at these apps, or even dissect them, if you will, we're going to think about some themes. Okay, and the first one's simplicity, which is to say we're going to strive for simplicity. These controls are not bleeding edge. It's not high-tech stuff. This is best practices. These things have been in place for years, if not decades, and that's okay. But simple doesn't mean easy, right? Sometimes, digging a ditch is simple, but it's not easy. It requires effort. And so the same's true here. Another one's common sense. So when we look at this app and we try to figure out, should we do security here? If it makes sense from a common sense perspective, we're going to do it without regard to expense or effort. We're just going to do it because we're going to look at what it looks like if we just throw everything at it. And then I'm going to use household analogies to try to explain to you the rationale and try to convince you that I'm not nuts, that some of these controls really make sense. There are some caveats. This is not cloud native. This is not Spring Boot. This is not microservices. This is not big data. This is using Java platform. Again, these controls have been in place for years, if not decades. These principles would work in those other places if they're the Java platform, but I'm not designing that specifically. So this is all going to be centered around what we can do inside of Tomcat. And I've got another caveat is that I'm not looking at secure coding per se. Right? So if you're interested in cross-site scripting and blah, 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 go to OWASP. They've got that covered quite well. That's not here. This is authentication, authorization, confidentiality. I'm going to tell you how to load that up and lock that down. I've got a couple recommendations. The slides are loaded. I've spent a lot of time on these slides to provide links to all the artifacts. We're going to be looking at code. We're going to be looking at configuration. All these slides, you can see there's hyperlinks, which will take you to the code. It'll take you to the code that's in my GitHub account. It'll take you to the code in maybe the Apache Fortress repo. And so just put your pencil down and just kind of try to absorb it. We're going to be going really fast. And so if I'm sorry?
Are the slides in your GitHub repo?
The slides are actually published on the ApacheCon website. So if you go to the ApacheCon, for this conference and go to the slides, they're there. And so that's one of my recommendations is just try to understand because we're going to be moving fast. And my other recommendation is, because we have a lot of ground to cover, if you could save your, normally I welcome questions, but I've tried to pack so much into this that I don't know that we're going to have time if I have to stop. So I'm going to try to get through it in time. But if you're lost or whatever, by all means, tell me to slow down or whatever, and I'll try to answer your questions as best as possible. Okay, so this is the first example, the Apache Fortress demo, and we're going to be doing all of that. Okay, and so in order to do that, you're going to go to this link and you're going to follow the instructions. You're going to generate the Java doc, and you're going to follow these instructions here. And it's going to tell you how to install all the infrastructure in order to have this app running on your machine. Okay, and so we're going to have infrastructure like we're going to have an LDAP server, we're going to have a database, and we're going to be doing things with that. So all of the steps to do that is in the actual documentation for the tutorial. So I'm not going to be going over this procedurally. You can do that later if you want to. We're going to be focusing on the concepts of what's going on inside of here. And actually, we're going to be dissecting this application from the outside in. We're going to be looking at all these layers, and we're going to talk about it conceptually. So speaking of layers, this is Java. It's a Java platform, and so this is what we have available. So you know, you say, well, where can I do security in a Java web app? You can do it in those places. And so on the outside, you've got the Java Secure Socket extension. That's the outer layer. That's for confidentiality and integrity, which we all know. One layer is JavaEE security. A lot of developers don't like it. It gets in their way. I know all that. I've been a security architect for over 20 years. I've fought that battle many times. Okay, so I understand. But we're going to use it for authentication and coarse-grained authentication in this demo. Okay, and then another layer in Spring. So we're in the middle. Spring does everything. But we're going to use it for securing the pages, which is medium grain authorization, if you will. And then another step in is the web app. We're going to be doing programmatic controls there. So there's a lot of ways to do security, right? So I'm not telling you this is the way to do it. I'm just saying this is a way. This is an idea. I don't want you to think, oh, I got to do it this way. It's just, I want you to do security in that layer, okay? Why? Because that's where those controls are, right? And you can't control buttons and things like that from a URL on the outside or whatever. You got to go down in there. And you got to put the controls down in there. So I'm going to do it programmatic. Just as long as you do it, that's fine. The fifth layer is the database. That's the deepest, darkest layer. That's where security architects rarely go. We're going to go there today. Okay, so am I crazy? Why are we doing security in all these places, right? So on the outer, so here's my idea of the rationale. So JSSE. Okay, why do I need to encrypt it? Well, it's kind of like when you're in an everyday situation, you talk to your wife, and the topic becomes important or sensitive. You're going to lower your voice so somebody doesn't overhear you. Why? Because you care about that person and you don't want harm to come to them. The same is true in a web app. We care about our users. We care about our providers. We ought to encrypt it, period. JavaEE security, what's that for? That's the deadbolt on the front door. Okay, so it's fail-safe, it works, you don't have to do anything, you put that deadbolt on there, you lock it, you keep the people that you don't want in the house out, and you keep the people you do want in the house inside safe. The third layer is Spring security, that's the locks. You're in the house, you're in the building, what rooms can I enter? Can I put locks on those doors in the building? Common sense would say that there's a way in which to do that, right? In a web app, you can do that with Spring security, and today we're going to look at that. The web app framework, we're getting deeper, further in. We're in the room. What can we do when we're in the room? What equipment can we operate? Can we lock down things in that room? Is there a way in which to do that? Again, common sense would say, like, you got small children, maybe there's a bandsaw in there. Can you keep them away from that? Common sense would say that there's a way of doing that. Today we're going to use the web app framework to do that. Finally, we're all the way inside. We got to the database. Why? That's content filtering. You can get in the room. You can operate the equipment. Say you can operate the TV. Can you control what channels they can hit? If you got children, common sense would say, yeah, you could probably filter that content. The same's true in a web app. You should be able to filter that content. The database function's the way to do it. I'm going to show you a programmatic way to do that. But it's important to do. You ought to figure out a way to do it. Okay, so these controls, these layers are all operating in two large areas of access control. The outermost layer is declarative, which means programmer unaware, right? You just enable it and it works, okay? And that's JavaEE and Spring. And then the inner layer is going to be programmatic, so we're going to have to call an API in order to do this. So we got to get the programmers involved. Okay, so I'm an Apache guy. I'm Java. I like Tomcat, so I'm going to start there. First thing I'm going to do is enable HTTPS, of course. It's both easy and simple. So for this example, we're going to need some cryptography artifacts, and so we can use OpenSSL. So I tell you about that right there. All the steps you got to do. Once you've got that key store generated, you're going to path it into the server.xml with the password. You're going to restart, and off you go. Okay, so while you're in there, go ahead and disable those weak Dixie-Hellman ciphers. And we're on to step 3, which we're going to put the deadbolt on the front door. Okay, so again, we're going to use JavaEE security, and we're still in the easy, simple realm. And so we are going to have to set the policy. So again, these, you want to look at it, click on the link. So this is, I already said it's coarse grain. So I'm going to prescribe a coarse grain policy, which is to say, do you have a single role to hit that app? Just one role. That's it. You can authenticate one role. So that is to say, hey, I can authenticate, but I don't want a user to just wander in to this app. And so that's the deadbolt, right? And that's it. So it's simple, it's easy, and off we go. Okay, so we got to bind that security system with something. So Tomcat uses by default the in-memory realm with or there's the file. Of course, that's not good practice. So we're going to show you a way in which to do that using the Apache Fortress system, which is my project. So we're going to use what's called the Apache Fortress Tomcat realm. And so we're still in the simple and easy, and so we're going to drop what's called the realm proxy jar in the Tomcat library folder. You're going to download that, and you're going to drop that library in there. And then that's going to map to dependencies that are in the actual web app. So I do that with a trick called a URL class loader. So, because I don't want you to have to put these dependencies on your system class path. That's bad practice. So all you got to do is put this little proxy on there, and then that's going to map to your web app. How do you do that? You're going to use a context.xml file, which goes in the meta-im folder of your web app, and you're going to specify the class name of the Fortress Tomcat Realm proxy. And then here we're going to say these are the roles that are allowed. These are the roles that are considered. Because you got a security system, you might have many apps, you might have hundreds of roles. So for this app, we only care about these. All right, so I already said something about dependencies in your web app. This is the Apache Fortress demo. It's a Maven app, so we're using Maven. So using Maven, it's easy to get dependencies in your app. You're going to specify the Fortress realm in your POM, and off you go. Okay, so we're done. We've got that enabled. Our next step is we are going to actually set up the security system itself, right? And so how do we do that? We're going to follow the instructions on one of these 2 quick starts. So this example will work with either Apache DS, which is the Apache directory, which is the directory server that's created by my project, or it would also work with OpenLDAP, which is a quite well thought of. Either one of those will work. And so we have in the Fortress project a quick start. You click on the link, you follow the steps. It takes about 10 minutes maybe to set that up. You're going to install a directory server, and you're going to configure it for usage, and you're ready to go. Okay? All right, so what the heck are we doing here? I mean, we got a security system. What is it doing? What is its capabilities of the security system? So I'm prescribing the usage of RBAC. What is that? Role-based access control. That is actually a standard by ANSI, Insights 359. I've been in this space for longer than I care to admit. I've had this slide in talks for years, and but this is the way. I'm not saying this will do everything for you for security, but I'm saying everything needs at least this. You start here, okay? And so it does. The specification outlines security in 4 broad areas. The base is RBAC 0. That's users, roles, permissions, and sessions. What's a session? The session is the context for which the role is activated. Just because that role has been assigned to the user doesn't mean it's going to be considered for usage in that particular decision. Okay? And so that's very, very important in a role-based access control. If it doesn't have a session, it's not RBAC. It's using roles for access control, which isn't role-based access control. They're not the same thing. All right, so we got these other things. I don't have time to go into it. That'd be a talk in of itself. What I do want to mention right now is RBAC 3, which is dynamic separation of duties, and that's mutual exclusion constraints between activated roles. I said earlier that roles have to be activated, so we can say that these roles don't go together. So you might have a role that's like check writer. I'm a check writer. I can write a check. I've got a role for that. I might have another role for check approver. I can approve it. I can be assigned both those because maybe I could do one or the other. But I can never do both at the same time because that would create the opportunity for fraud, right? So these are the kinds of things we're talking about. You follow standards, you follow best practices, and you are going to be on the right track. Okay, so we're going to talk more about that in the demo. All right, so this RBAC thing, it's a security system, so obviously there's going to be an entity model, right? There's data. So it's all the things that we as security people have known about for years. Users, roles, you got a permission. What's a permission? It's a mapping between an object and an operation. Page, add. Table, delete, right? That's a permission. You put those together, that's a permission. And then you have the session, I already mentioned that. Okay, so this specification actually tells you the shape of the APIs. So if you map in your app to this spec, then that means that you should theoretically be able to swap out that security system with another implementation. So you follow that model. So today, we're talking about this one. Those are the runtime APIs. Those are the APIs we're going to call programmatically in our application as we're doing our security checks. What are they? They're what you would expect. You can create a session, which is how you authenticate and activate those roles. You check access, that's the permission check. Can I do this? Bam. Or you can do session permissions, which is to say, give me all the permissions for this user, I want to cache them, which the Apache Fortress demo does. And then you got this add and drop active role. I talked about, this role that can be activated. You can actually add and remove roles in the process of a session. So we're going to be doing that here in just a minute. All right, so we've got the security system installed. We're in good shape, right? No, because we are sending data over the wire unencrypted, right? So you got users, passwords, roles, permissions. You ought to encrypt that, right? We care about our users. We don't want their passwords to be intercepted. Fortunately, it's both easy and simple to do. So in this application, we're using Fortress. Fortress has a properties file. So we are going to specify the trust store name and its password inside that property file so that it's available when it connects. Also the port, and that host name has to match the name that's in the certificate that you generated in the very beginning. On the server, you got to do a couple steps. If you're using Apache Directory, pull up the Apache Directory Studio, and you path in the location of that key store right there, and you give it the password, and you restart the server, and you've got SSL enabled. Or if you're using Open LDAP, you're going to take 3 artifacts that you generated in that first step in the keys. You're going to grab the private key, you're going to grab the server certificate, and you're going to grab the CA certificate, and you're going to path it into its configuration. And then you're going to restart that server, listening to the host name that's in that server certificate. And you're done. You got SSL. We're on to step 9. We're gonna lock the rooms. We're gonna put locks on the room doors. So we're gonna use Spring Security. We're still in simple and easy, fortunately. So we're going to, again, it's Maven. So we're gonna drop the Spring Security dependencies in our POM file. And then we are going to have to do a Spring thing, which we gotta tell it to use the Spring context file. So in this case, I'm using context file. Spring has lots of ways of doing config. This app's doing it that way. And then inside that context file, I got to establish the policy. So I already said that there's a page to role mapping to say, hey, I hit this page, I got to have this role. I hit this page, I got to hit this role. So that policy will be in that file, and we'll just say this, very simple. And then there is kind of a seam between JavaEE security and Spring. They don't quite exactly want to work together. They both kind of want to have control. So you have to kind of nudge it and say, yo, Spring, get the session from JavaEE. How do you do that? In your config file, you're going to enable the pre-authenticated authentication provider. How about that for a name? Okay, and that's going to tell Spring to go get those roles from the session from JavaEE. You don't own it, get it from the session in JavaEE. And then we got to tell JavaEE which roles to share in the web.xml file. Does that make sense? Okay, we're done, right? So now we have security all the way to the room doors, and we haven't even woken up the programmers yet. They're still off over there doing what programmers do when we don't need them. God knows what it is. So we're now inside the web app framework. We need them. So we're going to wake them up. What are they going to do? Well, they're going to add another dependency to the POM file to say, we need a few more APIs. We're going to do some more stuff. So they're going to add another dependency. And that one actually supersedes the one I said earlier, because that one includes the other one. And then we are going to use the Spring Beans method to inject those APIs into the runtime. So we're going to add the API manager to the runtime to make it easily available to those programmers. And then they got to do a little bit of work to smooth out the seam between JavaEE and the app. So we got to get the session from the container that it created in the very beginning and use it in the APIs. And so this is, you got to do a little bit of coding there. It's not too difficult. You got to get the principal from the container using the standard JavaEE API, and that principal is serialized. You're going to pass it to a Fortress API to say, turn it into the format you need it, and then you're going to push it into the HTTP session so we have it accessible programmatically later. Okay, and so this is kind of an idea of what that code would look like. Say you want to secure a button. So I'm using Apache Wicket for this application because I'm an Apache guy and I like Wicket. It's a quite good web framework. So that's the one I'm using. Whatever your framework is, this same kind of technique ought to work, something like this. But basically, we're going to override one of Wicket's buttons with this secure indicating AJAX button. And what that enables us to do is pass that permission into the constructor. Remember I said it's an object in an operation. So in this case, this button corresponds to page 1 add. Right? So you pass it in the constructor. And so if that user doesn't have that permission in their session, that button will not appear on the page. Furthermore, if it does appear on the page and they click on it, we're going to pass the customer number in there and say, see if they can hit that customer. And if they can't, we're going to throw an exception. And if they can, then life's good. So inside of this check access, it's just mapping to a little framework where there's a little bit of boilerplate code in there. Again, this is all behind these links if you want to look at it. All right, so we've now got the web app framework secured. We've got those buttons, controls, and dials that are now behind permission checks. So we're now into the database, the deepest, darkest layer of the application where we usually don't bother messing with. And so this application is using MyBetas, which is the simplest object relational framework that I could find. This same technique would work with Hibernate or whatever. So it's just, and basically we're just inside of the data access function, we're invoking a programmatic API again. So this is a fine-grained call. Again, we talked about page and operation. That page is actually a table name. It's a very simple app. It's got some tables, and then it's just tables are named after the page. That's a table name, that's an operation, and we're going to pass it the customer number. So if they don't have that, boom, they're going to get an exception. That's what the code looks like behind it. Again, you can look at it. All right, so we're almost done. We still got a problem. What is it? We're sending data over the wire unencrypted, right? We got customer numbers, it's going to the database, unencrypted. We ought not do that, right? We don't care, we don't care about cost or effort, right? We are following common sense. We know that that data should be encrypted, so we're just going to do it. How do you do that? It's about like before with LDAP. We got to path in the trust store and we already did that in Fortress Properties, so this app's going to use it. We got to change the JDBC a little bit to say use SSL, and then we got to do a little trick with Spring in the context file to say take those properties that we set and broadcast it on the system properties, because that's the way JDBC works. If you want JDBC SSL, you got to broadcast that trust store password on the system property, which I don't like. I think that kind of sucks, but that's the way it is. On the server side, it's like OpenLDAP. We take those 3 cryptography artifacts we said earlier. You got the CA certificate, you got the server certificate, and the private key. You're going to path it in to the MySQL config file, and then we're going to instruct the listener to listen to the host name that's in the server certificate. We're going to restart, and we're done. Okay, so we've now fully secured this. We've got this application that's running, and it has a policy. I already said it's kind of it's just a mock-up, right? So we got 3 pages, page 1, page 2, page 3. I've got 3 sets of customer data in the database corresponding to these customers. 3 pages, 3 customers. There's not, and then what I've done is I've established a convention that to the page customer there's a role. So there's a lot of ways to do this. This is the way I'm doing it here just for a demonstration. That means we got 9 page customer roles. Furthermore, I've established a dynamic separation of duty constraint on the activation of those roles, which is to say you can have one and only one of those roles active in your session at a time. So what does that mean? I'll show you here in a second. All right, so we've got some users in there. The first 2 are very powerful. We got super user, he's Uber. He's been assigned a role that has everything. So he doesn't have to go through the constraints. And that's an anti-pattern. He logs on, he can do everything. He's got all pages, all customers. Power user has been assigned all those roles, but he has to activate them one at a time. So I'll show you what that means. I've got a couple others. We can lock this down now any way we want. I've got user 1, 2, 3 has access to all pages for a single customer. user 1 has access to a single page all customer, and user 123 has access to a single page, single customer. This is running in our CenturyLink cloud environment. So I'm going to show you super user real quick. So he gets to the launch page. You can see he has those links pop up because he has the role to correspond to that. And then he clicks on a page and the buttons are there. So he already has that permission. You can see every page, the buttons are there. So this user, super user, can interrogate any customer on any page. And you can see, I enter in some data, it goes to MySQL, pulls that data back. Of course, this is all encrypted. So we have done that. But other than that, this is sort of an anti-pattern that we've given this guy too much power. We've violated the principle of least privilege. Okay, so what's another way we can do it? Let's log out and log in as power user, which again has been assigned to all those roles individually. And so when he logs in, then we have, you can see it looks similar. He has all the links to all the pages, so he can go to any page. Everything's fine, but there's no buttons down there, right? Because he hasn't activated the role to get those buttons. So you can see here, we've got this drop down with inactive roles. I click on that, and then those are the roles that are available for him to then activate. So if he, say, page 1, 1, 2, 3, he activates it. Now he can go to page 1, and you can see those buttons are there, right? They popped up. So now he can interrogate customer 1, 2, 3, or add, update, delete customer 1, 2, 3 on that page. If he goes to another page, there's no buttons, right? Because he hasn't enabled that one. If he tries to, on page 1, if he tries to interrogate a different customer number, say 456, he gets a security exception because he hasn't activated that role. It's checking that in the data access component and in the button. All right, so let's just activate that role. So we're on page 1. Let's do page 1, 456. So I activate that role so that I can operate on that. Man, this Wi-Fi is slow. All right, so, and then I get another exception right there. Activation failed due to dynamic separation of duty constraint. That means he's already got a role activated. So this is all happening in the policy decision point, not in the web app, right? So that's one of the advantages of having a security system like this. You don't have to bake that into the app. It's centralized. So before he can actually activate page 1, 4, 5, 6, he must deactivate page 1, 1, 2, 3. So let's do that. We deactivate that role, and then we activate the other one for page 1, 4, 5, 6. And you can see the buttons pop up, and now he can do that with 4, 5, 6. So this is a contrived example, but you could see that there might be some real use cases for something like this. All right, so that's power user. That's kind of comparison contrast, two ways of giving a user full power. One you're kind of limiting. So let's look at sort of a scope down user. Let's look at, say, user 1, 2, 3 that has access for all pages for a single customer. What does that look like? Well, let's log in. Is that user? Okay, so he has access to all pages for a single customer. So there's all the links to all the pages. Just like with power user, he clicks on one of those page links. There's no buttons down there. So this user would have to, just like with power user, if they wanted to get access to that, then they would have to activate that role. So I'm not going to go through that part again. What I do want to show you is this. So this drop-down box, he selected, say, page 3, 1, 2, 3. I programmed this, and I made a mistake, and I made that an entry field, right? So what's going to keep this guy from just saying, oh, yeah, I'm just going to give myself 4, 5, 6. I'm going to activate that. What's going to happen? Can't do it because he hasn't been assigned that role. So it's going to fail. So the policy decision point is cooperating with the web app and providing this sort of end-to-end holistic security. So that's an example of that one. I'm going to show you one more user, this user 1, that has access to a single page all customers. So what does that look like? Let's log in as that user. See that they got one link there, right, for page 1. Okay, that's good. Everything's cool. What happens if this user then tries to bypass that link and just go to the URL and change it to page 2, right? You know how users are. Can't do it because Spring's there, right? Spring knows that that user cannot hit that particular page. So this is practicing defense in depth. We've got security across many layers, and so these different layers, you have different capabilities. They all cooperate together, and so if any one layer breaks down, the other one picks it up. Okay, so enough of that. Where does that leave us? That's the Apache Fortress demo. Again, if you want to try that out, I encourage you to go to that link. I've been working on that app for a few years, and so it's pretty stable. If you have any problems, let me know. I'll fix it. Okay, so now we're on to the next one. Fortress SAML demo. So we're going to do this. This is kind of scaled back. It's not all. We don't have a database here. We don't have all the other things. But we're gonna change it out and not use JavaEE security. We're going to use SAML 2.0 instead for the endpoint, which is a common pattern. So again, this is in my GitHub. All the instructions procedurally to install it are there. I'm not going to go through those procedures one by one. We want to dissect this and figure out what's going on conceptually, which is how do we do all this? What does it mean? All right, let's start out with the layers. What happened to them? With our 5 layers, we've lost one. We don't have JavaEE security anymore. We've turned that off. We've moved the deadbolt down to Spring security because it's going to be the thing doing the SAML 2.0 endpoint. Okay, so we still have our 2 areas of access control. We have declarative, which is in Spring. We got programmatic, which is down in the web framework. We still got Tomcat. So now I'm going to deploy this thing called the Spring SAML demo. Why am I going to do that? Because I got to generate some metadata. So anybody here done SAML? You've done the metadata generation thing? You know what? Huh? It's a pain in the ass, that's right. So this is how I did it. So I prescribe it here is that you just pull down, say, the Spring SAML demo, you compile it, you build it, you push it into your servlet container, and that gives you a web form that you can enter in some fields, hit a button, and it generates that metadata for you. We're going to use that. And then once you go to that web form, you got to enter some values in the form. One is this thing called an entity ID. That's just an arbitrary value. It could be anything, but you have to know what that thing is because that's how you bind the identity provider and service provider together. That's kind of the tag that they use. Okay. And then we've got this called an entity-based URL. Before you do this step, you must know what that is. So if you must know what the host name is, you must know what port it's on, you must know the web context for that application. If you don't know that, don't do this step. Okay, so, and then you do that, and you hit submit. It creates this huge wad XML that looks uglier than hell, and you just put it away. You don't even look at it because it's ugly as shit. And then you just put it away because you're going to need it later. A couple tips. That entity ID is going to be mapped into the Spring metadata here in a minute. Okay, so now this is the one. They're live dragons. Set up how many set up an identity provider? Shibboleth? How many weeks did it take you to get it working?
I don't know.
A while, right?
I don't even know how to answer that.
I mean, you better pack a couple lunches on that step, right? So we don't care about that shit. We're developers. We're trying to figure out how to do security, right? So let's not worry about that. Let's use ssocircle.com. Anybody ever heard of that?
No.
It's really, really cool. So that's a SAML as a service. And so they'll host essentially an identity provider for you for testing. So we don't have to worry about it. So just follow the steps in the tutorial, and it takes about 5 minutes, and you got an identity provider. And then part of that step is you're going to set up a global user that you're going to log in as. Okay, so if you just want to know how to worry about the web app, do that. If you want to like lose some hair like me, then do the identity provider, and you can. It's fine. Okay.
Spring Security Act as a SAML identity provider.
I don't think they can do the identity provider stuff.
Okay.
I don't believe so. Okay, so now we are on step 3. We're going to take that metadata that we generated on step 1 and we're going to import it into our identity provider. Why? Because that's really the binding, right? And so how do we do that? We're going to log on to ssocircle.com and we're going to enter some values into a form. We're going to take that metadata that we don't want to look at. We're going to post it in there. We're going to hit submit and off we go. Couple things. This right here, this fully qualified domain name must be correct. It must match. We're going to click this attribute last name. It's because we want to send the last name in the SAML assertion. Why? I'll get to that in a second. We're going to post our metadata, and off we go. A couple tips. That fully qualified domain name that you entered into this SSO circle better match that domain name that you have in the entity-based URL, or you will not be successful. That's one of the tricks, all that, it has to be exactly right. If you get it exactly right, it'll work. And we're done. So we're now on to the user mappings. What does that mean, user mappings? Well, we got 2 repositories now, right? We got the global repository that's now in ssocircle.com, and we got the service provider repository that's in our web app that's this Apache Fortress directory. So we got to bind them. We got to link them, because I'm going to sign in as a user over here, and then I got to know over here on the web app how to map it. So who am I going to create a session for? Okay, so I already said before we used the surname. We told ssocircle.com to send the surname in the SAML assertion. What is surname is the last name. So this is just one way to do it. There will never be one mapping rule to work across all applications. Mapping is very specific to your partner. It could be email address, it could be customer ID, it could be a GLID, it could be an employee number. There's a gazillion ways to do that mapping. But for here, just to kind of give you an idea how it works, we're using a surname field, and then we're going to map that to the user ID in Fortress. Okay, so what does that mean? That means in the SAML assertion, after you've successfully authenticated with that web app, that surname value will actually be inside of that assertion, and then the web app will parse that, grab that surname, and establish a session. All right, so we are now on to step 5. We have to tell the service provider, which is our web app, about the identity provider. You got to say, hey, when I log in, or when somebody comes to me, go over there and do the authentication. Okay, how do we do that? So with ssocircle.com, we can use this HTTP metadata provider. So in our Spring context file, we're just going to put a URL back to the ssocircle.com, and we're done. We're now on to enabling that SAML authentication inside the web app. That's actually surprisingly easy to do using Spring. So again, we're still using Maven. So we're going to put the dependencies inside of our web app that map to the Spring SAML dependencies. And then we've got to tell the web app what is the policy, which is to say, hey, where are we securing it, And in our case, we're just saying it's all secure. If you hit any URL on this web app, it must be fully authenticated. And we're done. Okay, so now we have to, we've talked about doing stuff down inside the web app framework. We want to have buttons and stuff that are controlled. We want it to cooperate, so we got to do that work. So where are those programmers at? We got to go wake them up again. So we got to drop a Fortress dependency, because we're going to be using Fortress APIs in the POM file. And then we got to get that session. We got to get that identity from the assertion, and we got to create a session, right? And so how are we going to do that? We're going to get the principal from Spring using the Java Security API, get security principal, and then we're going to take that principal and we're going to parse it. And we're going to get the surname from it, and we're going to map it to the user ID, and we're going to feed it into our create session API to establish a session in Fortress, and we're going to say true. Is it trusted? It's true. We don't have a password. We shouldn't have to enter a password. We don't even know the password. So we're going to say true. That's going to create a session. We're going to take that product and we're going to put it in our HTTP session so it's available programmatically later. Okay, so that's what that parsing looks like. It's no big deal. Again, this is all inside of links. If you want to look at it, just go there and check it out. And so this is a simpler app. I've got a slightly different button, and and that code's right there if you want to look at it. But again, we got to pass the permission into the constructor, which is the name of the page and the operation, and we're done. Okay, so that's pretty much what's going on inside. We've dissected it. So let's just kind of see if it works real quick, and then I'll let you guys go get some lunch. So this is SSO Circle, and you can see here, this is my profile. So that's my global user ID right there. So when I log in, I'm going to use that. And then you can see that's the surname, right? Sam2. So back to this thing, we've got this very simple policy that is, again, 3 pages. And then I've got 4 users that are set up. Sam star has access to all 3 pages. SAM1 has access to one page, SAM2 has access to the second page, and so on and so forth. And so how do I set that? Because I only have one global account, right? And so we're back to this form right here where I'll just change, if I want to log in as one user or the other, I'll just change that value in the surname. Does that make sense? Okay, so let's just try it. See if it works. So I will pull up the link to the URL. And so let me log out first just to prove to you. Yeah, that's not part of the SAML protocol. The IAM row. Okay, so, all right, so let me hit this link again. Fortress SAML demo. It goes to the web app. The web app says, hey, I don't have your cookie. Go to the identity provider. All right, so here we are. We're at the identity provider. I'm going to enter in my global user ID password. And again, so the I am not a robot, that's the SSO circle. You know, they've slightly altered the SAML 2.0 protocol in a non-standard way. It's not even, it's outside the protocol, obviously. I'm just kidding. All right, so I'm not a robot, and there I am. So you can see that this session knows that I'm SAM2, right? So, and then I have access to that one page, and I've got the buttons on that page, as I talked about before. So if I wanted to then try a different one, say SAM star, we'll just do that real quick and see what that would look like. Okay, and I'm not going to log out. I'm just going to, well, I'm going to log out of the app, but not out of the identity provider. And then I'm going to try to re-log in back to the app. I go back through, I've already authenticated. My authentication cookie is still in my session, so the identity provider does not make me log in again. All right, I'm Sam Star. I have access to all 3 pages, blah, 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 right? So, so that's the Fortress SAML demo.
So you just keep changing the surname.
In this case, right? In reality, if you had an identity provider, yeah.
No, I'm used to
Yeah. Okay, so again, that's in my public GitHub account. This is also something that's been around for a few years, and it should work. I've tested it recently. It's all up to date using the latest Fortress. Both of these have been recently updated. If it doesn't work for you, file an issue with the GitHub, and I'll fix it. All right, closing thoughts. Encrypt. Just do it. If it's an endpoint, just encrypt it. Please. Apply security across many layers, which is defense in depth. Hopefully I've convinced you that that's a good thing. Never allow users more than they need to do their job, which is practice the principle of least privilege. And that's it. Here's my contact info.
You say